All right, guys. Now we are going to apply our diversity factor to our load analysis table. Okay. All right. This is what we have in our previous calculation for the ground floor. And what we are going to do now, we're going to use this for first floor as well. So that means this analysis is going to be for ground floor and first floor. Okay, so that I will save you the stress of going to the ground floor first floor to plot this table again. So we're going to use this table and use the load, whatever thing we got from here, we're going to multiply it by 2. Okay, so that we accomplish our load demand at once. All right, so let me walk you through how to apply the diversity factor. Remember, we have done that in the previous edition. So, but now I want us to do a recap. All right, now this is my lighting point. 1, 2, lighting circuit rather. I have 1, 2, and 3 as my lighting circuit. I have 3 lighting circuits here. So now I want us to apply diversity factor on whatever thing we recover as our total power, total load for the lighting. So let me flash you the diversity table once more. Here is the table. Now take a look at this table. We are working on individual household. We are doing residential installation. Remember the previous one was industrial and commercial. Now is a residential setup. So we are calculating for residential. So come for the column of residential. So we're going to use this column to apply the diversity on the lighting. Now trace this row. This is lighting. Under individual household category, you're going to be using 66%. 66% of the total current demand. I hope it's clear. The total current demand for the lighting circuit, the total lighting circuit is what we are referring to as our lighting demand. So we're going to apply 66%. All right. Now keep this table and come back here. We have 6.1 ampere, 7.5 amp, 8.6 amps, respectively for the 3 circuits. So total them together. So we apply diversity factor. If you total them, you're going to have 22.2 amps. Now, let me also tell you the reason for the diversity factor once again. You know that these 3 lighting circuits, the total lighting point for each circuit, look at it here, 13. 13 lighting point for circuit 1, 16 lighting point for circuit 2, 11 lighting point for circuit 3. Okay, now the whole of this lighting point, all of them, they are not going to be putting on at the same time. They are not going to be on simultaneously on regular basis. So because of that, we want to reduce the cost for the end user in order to drop the cost to make the installation more cost effective. Okay, we want to reduce the current carrying capacity of the installation before we determine apparatus such as changeover, service cable, generator sizing, transformer sizing, and the other associated equipment that will be utilized by the equipment by the building. So we want to reduce the size of these things I just mentioned. Please take note, diversity factor does not apply to distribution board. Distribution board calculation remain the way it is. It's only way you want to size the service mains, size the changeover, size your bus bar, size your generator. These are the areas where you reduce the current carrying capacity by applying diversity before you determine those apparatus. I hope it's clear. Okay. Now take a look at my current on my distribution board. It's still the way it is. I'm not going to apply diversity here. My diversity is another column. Take note, this one is the current carrying capacity for the distribution board. It remains the way it is. But we are reducing here because we want to determine other apparatus. We want to use this figure to accomplish other demand of equipment. All right, so let's go. We're going to reduce this current by applying the diversity. So now, because we are not going to put on the whole of this lighting point simultaneously, so we want to apply diversity by reducing the consumption by 66%. Okay, so we're going to diversify some and take some. We want to assume that they are not going to be on at the same time. So those of them that are going to be on regular basis is the percentage we are taking. Then those of them that are going to be diversified is the one that is going to be on regular basis. So we're going to use 66%. Now, total the whole of this, we're going to have 22.2 amps. Now, I want to apply diversity. So we're going to say this figure multiplied by 0.66. 0.66 is the diversity, is the 66%. So whatever thing I'm getting after this calculation is 15%. Look at it, it's 15%. It's 15 amps rather. Okay, now let me make it more elementary. Let me explain again before I bring another formula for you. This is my total current of the whole lighting point that I have, the whole lighting circuit here. If you total the consumption, the current wise, I'm going to have 22.2 amps. That is the total. Now, the 22.2 amps, I want to take 66% only. I want to use it for another calculation. I want to assume that 66% is going to be utilized on regular basis. Okay, 66% only is going to be utilized out of 100%. Okay, so I'm going to say multiply this by 0.66. What I'm going to get is 15 amps. So I've been able to reduce 22.2 and reduce it to 15 amps. So get your calculator. Let me show you something. Now we have 22.2. So going to be minus 15. So you're going to knock off 7.2 amps and use only 15 amps. So you have taken away this current from the total current demand. Okay, now the formula again is this 22.2, okay, divide by 100, okay, times 66. What do I have? 14.6, approximately 15 amps. I approximated it. I did the approximation before I got this. So this is 15 amps. Okay, so we are using 15 amps out of this. All right, so that is the application of this. I hope it's quite clear. All right, so let's go to the next one. Remember that this one is talking about the entire current here. Now come for the socket. Come for the socket. So go back to the table. Let me refer you to the table again. Come back to the table. Now we're talking about socket. Look at the socket. Okay, row 10. So trace row 10, come to individual household, the column of residential setup. So we are using 100% for the first circuit. Then the rest circuit is going to be 40%. So the first circuit, you take the current as it is. Then the rest of the circuit, take 40% only. Okay, that is the assumed current that is going to be utilized. So what I'm going to do, look at the circuit 1. Look at the first circuit for the socket. The first circuit is 18 amps. I'm going to leave it on 18 amps. Now the second circuit 1, 2, 3. 1, 2, 3. Yes. 1, 2, 3. Okay, this one is going to remain the way it is. This 18. So I'm taking 1, 2. Only these two. Only 2 is remaining. So these two, total them together, we're going to have 33 amps. So 33 times 0.40, that is 40%. You're going to get 13.2 amps. Okay, so the total current now for my ring is going to be 13.2 plus 18. That's the total current instead of 18 plus 18 plus 15. All right, I hope it's clear. Okay, so my total current for the ring circuit is 13.2 plus 18 only. Okay, so I've taken away the rest. All right, so now come back to the power. The power 1, 2, 3, 4, 5. We have 5 power. So go back to the diversity factor. Come back to this heating and power. Heating and power. Now the first power is going to be 100%. Then the rest is going to be 50%. So go back again. come back to this. This is 11.5. So we're going to take the circuit one of the AC is going to remain the way it is. Then the rest being 1, 2, 3, 4. That is 4 AC. We're going to apply 50%. So if you total the whole of this, it's going to be 46 amps. Multiplied by 0.50, that is 50%. I'm going to have this 23 amps. Okay. All right. So I have taken this 50% of this. So my total power for my power circuit is 11.5 plus 23 amps only. Okay. Instead of 11.5 times 5. Okay. All right. So that is it. Now, another one that you must have to pay special attention to is my cooker control unit. Okay. Okay. Sorry. Rather, we are still having first, yes, this one is cooker control unit. That is the next. So take a look at this cooker control unit. Remember, the power is 4,500 watts. Okay, and the current carrying capacity is 19.5. All right, 19.5. So what I'm going to do, I'm going to show you how to calculate this. Let's use another video to make it more faster. Okay.